if, elif, else statement. So now we're able to do the most general form of an if statement, which includes an if and an else like we've seen, but also elifs. So you can say if, elif, 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 else, as many elifs as you want. And it's if this test is true, do this body. Elif this test is true, do this body. As many more elifs as you want. And finally, the catch-all else, which says if none of those were true, do this body. So when you have an if, elif, 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 else, exactly one of those bodies is going to be executed. If you don't have an else statement, if all we had was an if, elif, then there'd be either one executed or the possibility of none. If none of the conditions is true, none of the code would execute. So let's look at this code and see if we can follow what it's going to do. So let's paste it here. Maybe take this down a little bit so we can see everything and go right here. All right, on f of 0, we get into here and we'll do A, it is 0, B, C. At that point, you skip the entire rest of this if. You don't do the elif, you don't do the else. So it says A, B, C, and then H. For 1, you do the A, you get in here, it's not 0, it is 1, so you do the D, and then you skip the entirety of the entire. You don't do the else clause because you match the elif clause. So you skip the entire if, elif, else at that point. So we did A and then D, but you still have the H because it's afterwards. For 2, well, you do the A. It's not 0, it's not 1. We get inside here, so we do the E. So we've done A and E. It is 2, so we do the F. Noting you can put an entire if statement entirely inside a clause or a body of another if, elif, or else. So it was 2, so we do F. Then we skip this else, and we do H. Finally, for 3, well, we do A, it's not 0, it's not 1. We get in here, we do the E. It's not 2, so we do the G. When we run this, we have ABCH, ADH, AEFH, AEGH. So it looks like we know what we're doing. Let's do some more interesting examples. If you want to do the number of roots of y equals ax squared plus bx plus c, well, that's based upon the discriminant, so we find the discriminant. If it's positive, there's 2 roots. If it's 0, there's 1 root, and if it's negative, which had to be an else, there's 0 roots. So this is a nice little piece of code that correctly tells us the number of roots of quadratic equations. And here's another one for you that uses a bunch of elifs. It's converting a score of a grade into a letter of a grade. Grades greater than or equal to 90 or A's. And on the elif here, you can only get here if we didn't match the A, the greater than or equal to 90. So we only have to test if it's greater than or equal to 80 because we know for sure by this point it's less than 90. Similarly, at this point, we know for sure it had to be less than 80 and so on. So that by the time you get to this else, it could only be true if you didn't score a grade, if you didn't have a score that would match any of the previous tests. So these are actually real world examples. This is basically how you would code number of roots or get grade. As we've learned from ABS, there's usually a great many ways to solve even simple little problems like these. But using if and elif and else in this way is a fine way to solve problems of this nature.